Welcome guys to today's class. In today's video, we want to discuss another important topic in physics, and that is motion. Yes, that is one of the first topic in physics, so to speak. So we will discuss the definition, the different types of motion we have, then go in details to discuss the types of motion, one after the other. Okay? Okay, let's start with the definition. Definition of motion. When we talk about definition of motion, whenever you hear motion, in a simple word, motion simply means movement. So if I want to tell you that you are moving, it means I can tell you you are in motion. Yes, because motion means movement. That is, movement of a body from one point or place to another. I take it again. Motion simply means movement of a body from one point or place to another. In another way, motion can also be defined as change in position of a body. Look at my position now. When I move to the next position, I have moved. I have embarked on motion. Are you getting the point? So whenever we are discussing motion, it simply means we are going to discuss movement, so to speak. Yes. There are different ways a particular body can move. Yes. And different bodies we have in this life have different movements they can embark on. Yes. Let's look into different movements a particular body or different bodies can embark on. That takes us to what? Types of motion. Types of what? Motion. Number one on our list is what we call random motion. Random motion. Yes. What do we mean by random motion? Whenever you hear random motion, we call it a disorderly motion of a body. A what? Disorderly motion of a body. A disorderly motion of a body from one place or point to another. Take for instance, motion or movement of housefly, mosquito, how they move, hawk, eagle, birds, all those flying insects, all of them embark on random motion. Yes. So random motion means a disorderly motion of a body. You can also say it's a zigzag motion of a body because they move randomly. They move random. You can't predict the direction they will move because they move randomly. So if you check hawk, check birds, mosquito, butterfly, housefly, how they move is always regarded as what? Random motion. Next on our list is what? Oscillatory or vibratory motion. Oscillatory or vibratory motion. What do we mean by this type of motion? This type of motion is simply a to and fro motion of a body. To and fro. The to and fro can be vertical. Yes, it can be in a vertical pattern. To and fro. To and fro. Or it can be in horizontal. To and fro. To and fro. So when we talk about oscillatory or vibratory motion, it is a to and fro motion of a body. Yes, whose acceleration is directed towards the center of fixed position and is directly proportional to displacement. I take it again. Oscillatory or vibratory motion simply means a to and fro motion. A to and what? Fro motion of a body. whose acceleration is directed towards the center of fixed position and is directly proportional to displacement. What examples do we have here? Motion of a simple pendulum. Yes. Motion of your swing. That your swing that we used to play in the field. Yes. It is a what? Oscillatory motion. It used to move like this. Are you getting it? Even simple pendulum, some of them move like this. Some of them move what? Up, down, up, down, up, down. It depends. Are you getting it? Even motion of a talking drum. Motion of a talking drum is embark on vibratory motion. Up, down, up, down, up, down. To and fro motion of a body. Are you getting it? So we have listed examples of oscillatory motion. We'll talk about simple pendulum, swing, yes, motion of a swing. Then we'll talk about talking drum and others. Then the next one on our list is circular or rotational motion. Circular or rotational motion. When we talk about circular or rotational motion, even though they have slight difference, yes, but they are majorly the same. Yes. Circular or rotational motion is motion of a body around a circular path. Motion of a body around a circular path. Are you getting it? Like motion of a your ceiling fan is under circular. Motion of a standing fan, even rotation of the earth, all of them move in a what? In a circular path. So motion of a body or movement of a body in a circular path or around a circular path is called circular or rotational what? Motion. Then the next one we have here is what we call linear or translational motion. Linear or translational motion. Now here we will be discussing movement of a body in a straight line. Movement of a body in a straight line, like movement of car in a straight line. Say linear or translation, because linear is a word for straight line movement, not random or not disorderly or zigzag movement, but straight line movement. We say linear or translational motion. We call it linear or translational motion. Movement of a body in a straight line. Are you getting it? It is here that you will see that loss of motion there. You will be seeing loss of motion in this fourth one. Yes, where we have V equals to what? U plus AT. S equals to what? UT plus half what? AT squared. Then S, then V squared equals to U squared plus 2AS. Then S equals to what? S equals U plus V all over 2 times what? T. Yeah, these are laws of motion. We'll be seeing them in this linear motion, so to speak. Yes, remember, these first three laws of motion are very important. These first three laws of motions are very important when we talk about what? Projectile motion. Projectile what? Motion. These first three are very important when we talk about projectile motion too. Yes, because when we talk about projectile motion, we are trying to discuss motion of a body under the influence of gravity. Yes, anytime a body is moving under the influence of gravity, we call it what? Projectile motion. Here you'll be having plus or minus, plus or minus, plus or minus. Yes, when a body is moving against the gravity, it becomes what? Minus. You'll be using V equals to U minus AT. S equals to UT minus half AT squared. V square equals to U square minus 2AX when a body is moving against the what? Gravity. But when a body is falling from up to down, are you getting it? When it's falling from up to down, something falling from a tree down, you say the sign will now be plus. Sign of A will be plus. Why we are concentrating on only the first three is because it is only the first three formulas that have acceleration due to gravity. Only the first three formulas that have acceleration due to gravity. So that is why they are applicable in projectile motion. When a body is moving from up to down, here will be V equals to U plus AT. S equals to UT plus half AT square. V square equals to U square plus 2AX. But when a body is moving from down to up, that is against the gravity, formula S equal to UT minus half AT square. V square equals to U square minus 2AX. Where A will be equals to what? G. Where A will now be equal to G when we are talking about projectile motion. The acceleration we'll be talking about will be called acceleration due to gravity. But we'll still discuss them. So far, so good. We'll still discuss them. Let's go to the second one, oscillatory or vibratory motion, and discuss it in detail. Because the first one, random motion, we say is a disorderly motion of a body. So we can't predict how the movement will go like. So it is this one now that we have to discuss, because this and the third, this oscillatory motion, circular motion, and the linear motion, they are very, very important as a physics student, that you know it very well. Okay, let's take oscillatory motion. Now, when we talk about oscillatory motion, we say this is the to and fro motion of a body whose acceleration is directed toward the center of fixed position, and it is directly proportional to displacement. This is the to and fro motion of a body whose acceleration is directed towards the center of fixed position and is directly proportional to displacement. Yes. What are the example? Example of a body that undergoes oscillatory motion is simple pendulum. Simple what? Pendulum. Yes. Simple pendulum. That simple pendulum always embark on simple harmonic motion. It always embark on simple harmonic motion. Remember, this oscillatory motion we are talking about, it can come in many ways. It can be vertical motion, like up and down, up and down, up and down, as you see in ruler. Let's take for instance, look at this ruler now. If I clamp this ruler and if I clamp it on a desk or bench and I displace it down, it will be moving up and down, up and down, up and down. The rule that is very important to be obeyed while embarking on simple harmonic motion per se is, while you are displacing this, you displace it at a very small angle. Once you displace it at a very small angle, it will not be moving too fast. It will be moving slow, so that you will be able to do your counting very well, and at the end be able to what? Get accurate results. Then remember, we say it can be up and down, up and down, up and down. That is the motion. The oscillatory motion can be up and down, up and down. It can also be as you see in string or spring. Yes, if you displace spring, if you displace it down, it will be moving up and down, up and down. It's still embarking on what? Oscillatory motion. Then we also talk about the Janglover own motion of a swing. Yes, that one we call Janglover, that will be moving like this. Somebody will push you, you move up, move down, move up, move down. Yes. Then another example we forgot to talk about here is motion of a simple pendulum bob, motion of a simple pendulum bob, it also move to and fro in a horizontal way. So it can be horizontal movement to and fro. It can be a vertical movement up and down, up and down. All of them is oscillatory what? Motion or vibratory motion. And so we want to look into simple pendulum. Yes, simple pendulum, motion of a simple pendulum, since it's obeying oscillatory motion, because that will help us to see important formulas that we should know or we must know if we want to do well in this topic. Yes, formula for finding velocity at the center, velocity at the extreme position. Let's discuss it. Look at your look at a fixed point and you clamp your pendulum bob. You just clamp your pendulum bob. Now, as you clamp this pendulum bob, maybe using a thread, you use a thread and you clamp this pendulum bob. This is a bob. Then, if you displace it at a very small angle, very important, because the rule or the precaution to obey while embarking on this is ensure you displace it at a very small angle. Yes, that will help you to get accurate result. So if I displace it at a very small angle, it will be moving like this: 1, 2, 3, 4, 5. I'll be able to count my number of oscillation correctly. Are you getting it? So watch how the movement will go. So this is just a sketch of how a body that undergo simple harmonic motion goes. Yes, in this case we are discussing simple pendulum bob, how it undergoes simple harmonic motion. Now it is important we label this diagram, this sketch we just made here. This is what we call extreme position. Extreme position. Then here is also extreme position. Then this is what happened at the center. This is the center of it. So we will be discussing what happened at the extreme position and what happened at the center. Okay, this bulb is displaced vertically this way, so we call this the displacement x. But still remember that we said simple harmonic motion is a to and fro motion of a body whose acceleration is directed towards the center of fixed position and is directly proportional to displacement. So what are they trying to tell us? From this our diagram, we will derive formulas that are very important to know about, so that we use it to solve different questions we have in this topic, and from there be able to explain why we say that the acceleration of it is directed towards the center. Yes, and the implication of acceleration being directed towards the center. Okay, now this is your what? The displacement x. Are you getting it? Now here is called the amplitude. Amplitude means the maximum height, the highest point a particular body that is being displaced or that is embarking on what? Simple harmonic motion. The highest point it can get to. Look at this now. It will move to up here, move down, move up here. So the highest point they can get to, we call it amplitude. Are you getting it? So we want to derive some formula. But before we derive some formula, let's explain important terms. Important terms. Number one term we want to discuss is amplitude. Amplitude. The second one is what? Frequency. Third one is period. Yes. Kinetic energy. Potential energy. Yes, we want to define them, just a way of remembering what we know. And after defining them, we'll still tell you how to locate the kinetic energy, the potential energy, the velocity at the extreme point at the center, how to do their calculation very well. Yes. Amplitude, as I said, is a maximum height or the highest point a body that undergoes simple harmonic motion should get to. So this body now, called simple pendulum bob, the point it can get to, the highest point it can get to, we call it amplitude. Then frequency. Frequency simply means number of oscillations or cycle that is being covered in 1 second. Number of oscillation or cycle covered in what? 1 second. And that is why we say frequency is equal to what? N over T. Number of oscillation or cycle covered in 1 second. Period is the next. Period simply means time it will take to cover one oscillation or cycle. The time it will take to cover one oscillation or cycle. If you notice in frequency, frequency is n over 2 and the unit is per second or hertz. The unit is per second or hertz. But if you notice in period, the unit is in seconds. This is t over n and this is n over t. That means they are opposite of each other. We can say therefore frequency is equal to 1 over period. Capital T is called period in physics. Are you getting it? Or period is equal to 1 over frequency. Are you getting it? Then when we talk about kinetic energy, the energy a body possess while in motion, that is what we call kinetic energy of a body. The kinetic energy of a body is the energy a body possess while in motion. Yes, the unit of it is in joules. Are you getting it? Then potential energy, the energy a body possess while at rest. Are you getting it? When a body is at rest, the energy it possess is called what? Potential energy. Its unit is also in joules. Are you getting it? And so we'll go in details to see how to derive formula for what? Velocity, acceleration, potential energy, kinetic energy at extreme position, when the body is at extreme position and when the body is at the center. Okay? Now, to do this derivation, watch what you do. Can you see this shape? Here is also amplitude. Can you see this shape? Can you see this shape? You can take any of them. Watch. I am taking this shape because they are just the same thing. I want to take one of it. Now, look at the angle. Look at the angle. Can you see it? The displaced angle, so to speak. Remember we said this angle must be very small so as to what? Minimize error and get accurate result while doing the experiment. So you have to what? Displace it at a very small angle that it will not be moving as fast as possible. If you displace it too high, it will make a very big angle and it will be moving as fast as possible. But if you displace it just small, it will be moving small small. One, two, do you get the point? Okay. Now this shape now, When I bring it like this, watch it. It will go like this, then go like this. So this is the amplitude, and this is that your theta. Can you see it? And this is that your x. Yes. As you see this now, remember this, we call it displacement. We call it the displacement. Why we rotate it like this is to be able to do our derivation. Are you getting it? So as it will be easy for us to do our derivation and understand what we are doing. Okay. Now, we are now saying that this A is in between the vertical y and what? The horizontal x. This A is in this amplitude is in between what? Vertical y and what? Vertical x. Horizontal x. So because this A is in between this y and this x, all we do is that we will resolve this A such that we will get the share for y and get the share for x. But the one I need is the share for x. That is it. Because that is the displacement we are seeing on the diagram here. Okay, now, using the principle of resolution of vectors, because displacement is a vector. Are you getting it? I'm now telling you that because this is in between y and x, to give the x its own share, because this x is at the horizontal side, you must make the angle, make use of the angle that this A make with horizontal. You must, is a must, make use of the angle that this vector A, this A, make with what? Horizontal. Because this is our what? This is our amplitude. You must make use of the angle that this A make with what? Horizontal. To get the value of this what? X. Watch. X will now be equals to, I will now say, resolving A to this horizontal, we say A cos theta. Why are we using cos? It is because we are trying to give the share for this horizontal aspect. Are you getting it? Then, if I want to give y its own, I will say y is equals to what? I will use sine. And I must also use the angle it make with what? Horizontal. Do not say 90 minus theta, that is this side, 90 minus theta, and use it for y. No, it is a mistake. What you do is you say, make use of this angle it makes with horizontal is a must to resolve for the one of x and also to the resolve for the one of what? Y. The only difference is that the one of x will be having cos and the one of y will be having what? Sine. That is just that. So this is what? A sine what? Theta. But in this diagram, we only have letter x to make use of. Are you getting it? So I will be going with one of x, which is our displacement. Okay, look at my x now, A cos theta. In circular motion, we noted that theta is equal to what? Wt. Not so? Yes. Theta is equal to product of angular velocity times time. And so, coming here now, we say this is what? X equals to what? A cos Wt. Because we know this. Are you getting it? Yes. Why are we using the principle of circular motion, or principle we have from circular motion, which is theta equals to Wt? Why are we bringing it here? It is because in this simple harmonic motion, it is a to and fro. It's moving more of in a circular motion. More of in a what? Circular motion. So its to and fro motion is in a circular what? Motion. That is why we are using that information, theta equal to Wt. That noted. So your displacement x is equal to A cos Wt. Now let's go again. Do you still remember that? Do you also remember that velocity is equal to displacement over time? Velocity equals to displacement over time. Whenever you see something like this, This is a formula. Velocity equal to displacement over time. What is your displacement? You say your displacement is x and your time is t. Whenever you have something like this, let me tell you what it means. It means that to get v, I'll differentiate x with respect to what? T. You say I add dd up and down. When you differentiate x with respect to t, you get velocity. That is information. And so bringing it here, differentiate dx over dt is equal to what? V, and is equal to what? We want to get our velocity. We want to differentiate this x with respect to t. And how do we do that? What is the number or what is the letter beside this t? You say it's w, right? So to differentiate a cos wt, I will say write a. What is the letter beside this t? You say it's w. You bring it out. I have differentiated wt to get w. Then I multiply it to this a. You become aw. Then differentiate sign. When you differentiate cos, if you differentiate cos in mathematics, it means what? Minus sign. That is from calculus, differentiation and integration. Whenever you differentiate cos, you have minus sign, then you attach wt to it. That means your v is equal to minus aw sine what? wt. Can you see the formula for velocity? Minus aw sine wt. Yes. Now, as you have gotten this now from differentiation of x, which is your displacement, as you have gotten velocity from differentiation of displacement, this velocity, if you are squaring both sides, what are you going to get? Because we want to finalize the actual formula for velocity of a body that undergoes simple harmonic motion. Are you getting it? Now, squaring both sides. If I square v, I will have v squared equals to square minus a. Minus a square will give you a square. W square will give you w square. I am squaring both sides. That is what I'm doing. Sine w squared, sine wt squared. Watch. Remember again that sine wt means sine theta because of what? Wt means theta. Are you getting it? Because theta is equal to wt. That is this. So if I square sine theta squared, if I square this sine theta, what is it going to get? Or what am I going to get? Is it sine square theta or is it sine square theta square? Which one is correct? The first one is the correct one. Just note that. And so we say that sine theta squared is sine square theta. Minus a square is a square. W square is w square. Sine theta square is sine square theta. That means sine wt all squared simply means sine squared wt. Please do not make mistake of saying sine square w square t squared. That is wrong. And so we'll be having here to be what? Sine squared wt. As we have gotten this, still remember that from trigonometry that we were told that do you remember that cos square theta is equal to 1 minus sine square theta from trigonometry? Yes. And that means sine square theta is also equal to 1 minus cos square theta. That means when this go here, it becomes sine square theta equal to 1 minus cos square theta. Do you believe that? Okay. So, having noted this, I will remove sine square wt. That means this is sine square wt equals to 1 minus cos squared wt. Okay, so bringing it here, we'll be having v squared equals to what? A squared w squared bracket 1 minus cos square wt. Are you getting it? Now, what you do here now is what we call rearrangement now, or packaging. Oh yeah, see how we package. I'll keep w square outside this bracket and carry a square, bring it inside here. Bringing a square inside here, see what I will get. W square bracket a square times this, a squared, minus a square times this, a squared cos squared wt. Can you see what we get? See, also remember that, you see, physics and mathematics, they are like brothers. Are you getting it? Physics and mathematics, they are like brothers. See, also remember that a cos wt all squared is what we called what? A squared cos squared wt. This is equal to this. Yes. And remember that a cos wt, a cos wt is your x. That means this is x squared. Can you see what I am doing here? A cos wt x squared. Are you getting my point? And so I will come here now and say that v squared will be equals to what? W squared bracket a squared minus x squared. So I have succeeded to derive my velocity in terms of angular velocity, to derive my linear velocity in terms of, to derive my velocity, this velocity in terms of angular velocity, amplitude, and what? Displacement. Yes, because we have amplitude, we have the displacement, and now this is the velocity. We call this velocity of a body undergoing what? Simple harmonic what? Motion. Yes, I have gotten that. That means my v square is equal to w square a square minus x squared. Now let me tell you something. When the body is at the center, what happened to x? X is at 0. X is at the starting point. Once the body is at the center, it means the body is at the starting point 0. Are you getting it? That means x will be equal to 0. If you put it here, what are you going to get? And what am I trying to tell you now? If you put it here, you'll be having v squared equals to w squared bracket what? A squared minus 0 squared. And 0 squared is what? 0. A squared minus 0 will give you a squared. That means you'll be having v squared equals to w squared a squared. This v, therefore, if I remove this power of 2 here, I'll be having what? Square root of what? W squared a squared. And what is the square root of w squared a squared? It's simply what? W a. So velocity of a body undergoing simple harmonic motion, the velocity of it at the center is always equal to product of angular velocity times amplitude. And that is why we say the velocity at the center is maximum. The velocity at the center is equal to what? Maximum equals to what? W a. That is about that. What about at the extreme position? What will be the velocity? So this is velocity at center. So when a body is undergoing simple harmonic motion, the velocity at the center, the velocity of that body at the center. Are you getting it? If you are talking about simple pendulum bulb now, and we are using it as a body, for instance, the velocity of that body at the center, as far as it's undergoing simple harmonic motion, is equals to angular velocity times amplitude. Once you multiply them, you have gotten your answer. Are you getting it? Now, I want to get this velocity at extreme position. Velocity at extreme position. Velocity at extreme position. Now, at extreme position, it's important to know that at extreme position, this x must have gotten to this amplitude. That is how it gets to extreme position. So at extreme position, x will be equals to a, because the x is no longer at the center. It is now at the what? Amplitude point. At the amplitude. So x is equal to a. So here will now be x equal to a squared. A squared. So a squared minus a squared will give you 0. 0 times w squared is 0. You will be having, therefore, here will be v squared equals to 0. Therefore, v is equals to 0 meter per second. But for velocity at the center, it means I will just say v equals to, get the what? Angular velocity and multiply it by what? Amplitude. Are you getting it? But if the angular velocity is not given to you, if the angular velocity is not given to you, you can say, or you say 2 pi f. You multiply 2 times pi times the frequency, then times the amplitude. You can still get your velocity by that. Or you can also multiply, or you can also say 2 pi over period times what? Amplitude. 2 pi amplitude over what? Period. You get the velocity at the center. That is, if angular velocity is given to you, this is this. If it is frequency, this is this. And if it is period, this is the formula that you will use. Are you getting it? So at extreme position, v will be equals to 0. V will be equals to 0. But at the center, v will be very much maximum. Are you getting it? That is that. Then it's also important for us to note that we can get the acceleration of a body that is undergoing simple harmonic motion. Let's get the acceleration. To get the acceleration of a body undergoing simple harmonic motion, remember that velocity is equals to what? Minus what? A w sine wt. We got it before we were able to what? Rearrange it or simplify it further to get the final formula. So this formula is a formula we should not forget, that velocity of a body undergoing simple harmonic motion is equal to, if I remove power of 2 here, I'll put square root here, right? So that will be w square root what? A squared minus x squared. Because when I square this, I get w. When I square this, I can't get this answer. I package it like this. That is velocity of a body undergoing simple harmonic motion. Velocity of a body undergoing what? Simple harmonic motion. Undergoing simple harmonic motion. So this formula is the formula you will be, once you know your what? Amplitude, and you have been given the displacement, the particular point they are talking about, because it might not be at the center, it might be at so point here, at so point here. So they must give you the particular what? Value for what? Displacement. If it is not at center or at extreme point, you can, or you must be given a particular value for what? Your displacement, so that you now put it here. Or is equals to what? 2 pi f root what? A square minus x square, as I said before now. So all these are formulas we should not forget. Yes. Now we note that it is from this formula that we got the actual formula for velocity. Yes, It's from this formula we derive the actual formula for velocity. So to get the actual formula for what? Acceleration of a body undergoing simple harmonic motion, we still continue from here, which we use to get the one of velocity so that we get the one of acceleration, right? Remember that acceleration is equal to v over t. That means when you differentiate v with respect to t, you get acceleration. Let's differentiate. We say the v over the t is equal to acceleration and is equal to, what is the letter beside this t? You say it's w. Are you getting it? So I will be bringing out the w. So AW, I will have minus AW times, what is the letter beside this w? Because we are differentiating with respect to t. That is what this formula is telling us, with respect to t. So the letter beside the w, we pick it. So times w. Then we now say differentiate sign. If you differentiate sign, you will be getting what? Cos. Then you attach w what? T. Are you getting it? So we will be having that, therefore A will be equal to, when we multiply out, minus AW times W will be giving me minus what? AW squared. Are you getting it? Then cos what? WT. Can you see the formula? But remember that, note that our x is equal to what? A cos WT. We have this from the beginning. Our x displacement is equal to A cos WT. So if I take this and this out to replace it with what? X. I'll be having A will be equals to what? Minus what? W square what? X. I've removed A and cos WT and replace it with what? X. So this is a formula for a body that is what? This is formula for acceleration for a body that is undergoing what? Simple harmonic motion. Yes. Now, do you notice that the formula for this acceleration is carrying negative sign? Yes. Remember, from the definition of simple harmonic motion, I said I will explain why we say that the acceleration is directed towards the center. Whenever a vector quantity is directed towards the center, we say that the what? That vector quantity will be having a negative sign while you are solving it. Or watch what I mean. If you have a Cartesian axis like this now, and we have something like maybe an arrow, this denoting acceleration directing towards the center. It means that because this arrow is directed towards the center, it will be assigned a negative sign. Reason, because it's directed towards the center. One can ask us in exam, why is it that acceleration of a body undergoing simple harmonic motion is having or must have negative sign? Or explain why there is a negative sign in the formula for acceleration of a body undergoing simple harmonic motion. You try to tell them that the negative sign represents or explains that the acceleration of that body must what? Be directed towards the center. Yes. Once the acceleration of a body is directed towards the center, it must be negative. And we said simple harmonic motion is a to and fro motion of a body whose acceleration is directed towards the center of its position and is directly proportional to displacement. So we should not forget the reason why we have minus here. Reason again is because it's directed towards the center. Now, what happened at extreme points? Extreme position. At extreme position, A will be equal to, at extreme position, this S will go to this point. X will be equal to A at extreme position. Are you getting it? And so our acceleration will be minus W square what? A. So if you finish solving the formula for, if you finish solving question on acceleration and you are not seeing minus in the option, do not say nota. because the minus is trying to tell you that it is what directed toward the center. It's just to call to attention that is directed toward the center. So in the option, you might see minus in the option, or you may not see the minus, whichever is the case. If there is no minus there, still go with your answer. Yes, because minus is telling us is directed towards the center, and it must direct towards the center. Then at center, at center, we said that at center x is equal to 0. So if x is equal to 0 times this, a will be equal to 0 at center. So we have a equal to 0. Are you getting it? Yes. And we have a equal to what? Minus w squared a for this what? At the extreme position. A equal to minus w squared what? A. Yes, at extreme what? Position. Yes. So when they ask you to get acceleration of a body undergoing simple harmonic motion at extreme positions, it means that minus w square times what? A. And I've told you what w mean. W can mean 2 pi f or can mean 2 pi over what? Period. So you just compute 2 pi f, then square it, multiply it to what? A. Do you understand it? So that is that. We now go to what? The one of energy aspect of it, because we need to know the energy of a body undergoing simple harmonic motion at extreme position at the center. Is very important we know them. Yes. Okay, we want to discuss the kinetic energy of a body that undergo what? Simple harmonic motion. Now, ordinarily, we know that our kinetic energy, which we said that it is the energy of a body that is in motion, is equal to half what? Mv squared. Now, what is the formula for velocity when we talk to what? A simple harmonic motion or for a body? What is the what? Formula for this v square when we talk to the one of a body undergoing simple harmonic what? Motion? We noted that it is equal to half m. This m is this. V means what? W squared bracket a squared minus x squared. We have derived it here. We have derived it here that v square means w square bracket a square minus s squared. And so formula for kinetic energy of a body undergoing simple harmonic motion is this. Now we want to now check how or what is the kinetic energy of a body at extreme position at center. Once a body is undergoing simple harmonic motion, what is the kinetic energy of it at the center or at extreme position? Okay, at the center, our x is 0. 0 squared, 0. A squared minus 0, a squared. So kinetic energy at what? Center is equal to half mw square a square. That is always maximum at the center. Kinetic energy of a body undergoing simple harmonic motion at the center, x is 0 because that is the starting point. 0 squared 0, a square minus 0, a square times this, you have this. So it is always maximum. So we say our ke here is equal to half mw squared a squared, that it is maximum here. It's maximum here. Are you getting it? It's always maximum here. Then What about the extreme position? Whatever happens to this extreme is also same with this. So what about extreme position? At extreme position, x is equal to a, because this x will move up here, so it is not equal to a. Are you getting it? We have a squared. A squared minus a squared, 0. 0 times this. So ke at extreme position, extreme position, extreme position will be equals to 0 joules. 0 joules. So we have ke here to be equals to 0, and ke here to be equals to 0. This is very important we know that. What about potential energy? Potential energy, that is the energy of a body at rest. Yes. Potential energy. To get our potential energy, remember that we have different formula for potential energy. Half Fe. We got this formula from what? Work done. Work done on a body that is what? Undergoing what? Hooke's law. I mean, undergoing ups and downs. Elasticity. Yes. You know, there is a topic we call elasticity in physics, where they told us that when you get a string or a spring and you stretch it, it will be moving up, down, up, down, up, down. And so it still undergoes simple harmonic motion. And from that topic elasticity, we say that work done on a string, which is kinetic energy, which is the potential energy of it, which is energy also, that is equal to half Fe. And we are also told that what? F. We are told that F is equal to Ke, because F is directly proportional to what? Extension. The higher the force, the higher the extension. So from here we'll be having what? Half Ke what? Squared. Because F is Ke times E, it becomes half Ke squared. That is about potential energy. Okay. Then bringing it to this what? Body that is undergoing simple harmonic motion. Your K, this K you are seeing now, is equals to mw squared. The K is equals to mw squared, where K is equals to mw squared. Yes. We see it when we discuss circular motion, body undergoing horizontal circular motion. We will see how we got this. Are you getting it? And E squared, the extension we are talking about, is equal to what? X squared. That is this, the displacement we talk about. Are you getting it? This is how it displays. So the extension is x squared. And so we'll be having our PE to be equal to half mw squared x squared. Yes. That means at the center, x is equal to 0. Therefore, when x is equal to 0, 0 squared is 0 times this. Everything will be 0. So at center, PE will be equal to 0. At extreme position, PE will be equal to, at extreme position, x is equal to a. Once we talk about extreme position, that is this moving up to this point, x will be equal to a. We'll be having what? Half mw squared what? A squared, because x is equal to a. That means at extreme position, PE is equal to half mw squared what? A squared. And that means that the PE is maximum here. PE is always maximum at extreme position, but at the center, PE is equal to 0. That is minimum. It's always minimum at the what? Center. And this is how we got all those stories that they told us in our secondary school, that when you have this at the extreme position, velocity is 0, A is maximum, Ke is what? 0, here is what? The same thing, and V is maximum, A is 0. Remember that this minus I wrote here, you may not see it in the option because it is just trying to tell you that acceleration is always directed towards the center. So you may not see it in the option. Yes. But they can ask you the implication of that minus. Very important. Then it's also important for us to note formula for total energy. Total energy. When they ask you total energy of a body undergoing simple harmonic motion. Formula for total energy of a body undergoing simple harmonic motion simply means the summation of kinetic energy and potential energy. What is our word kinetic energy formula? We'll go to here. Is equal to half mw square bracket what? A square minus x squared. Yes. Plus, what is the formula for potential energy? Look at it here. Half mw squared x squared. So how do we sort it out now? Oh yeah, expand this. We'll be having 1 over 2 mw squared a squared minus 1 over 2 mw squared x squared. Then plus 1 over 2 mw squared x squared. So these two we subtract and both of them will go out. So look at the formula for total energy. Therefore, it's important to tell you that since the total energy is equal to what? Half what? mw squared a squared. Do you still remember that this total energy is equal to kinetic energy of a body undergoing simple harmonic motion at center and potential energy of a body at what? Extreme position. So that means that the maximum Ke is equal to maximum what? Pe, and is equal to total what? Energy. Is equal to total energy. Maximum Ke at the center is equal to maximum Pe at what? Extreme position, and is equal to total energy, and is equal to half what? mw squared a squared. So when they ask you to get formula for total energy of a body undergoing simple harmonic motion, just remember half times mass times angular velocity squared times amplitude squared, where I've told you the other formula for W, that W is equal to 2 pi f or 2 pi over t in terms of frequency and in terms of period. And so we will go into question solving on this topic, simple harmonic motion, that is oscillatory motion per se. We will go into question solving on that because it's very important you know how to solve it. So if you find this video helpful, if you enjoyed it, don't forget to what? Follow us, subscribe, share, and comment. Okay, so let's see how to solve this problem we have on oscillatory motion. Yes. Question number 1. An object moving with simple harmonic motion has an amplitude of this cm and a frequency of 20 Hz. Find the period, the acceleration at the middle, at the end, the velocities. Now, how do we get the period for question number 1? Period is equals to 1 over frequency. Yes, because we said period is t over n and frequency is n over t. Therefore, since period is t over n and frequency is n over t, we say that period is opposite of what? Frequency. So period equals to inverse of frequency. That means we'll be writing 1 over what? 20. 1 over 20 will be giving us 0.05 second. Then the B, calculate the acceleration at the middle. At the middle. Remember we said from our derivation that at the middle, acceleration is equals to 0. So you don't need to calculate that because at the middle the acceleration is always equal to 0. Then for BII, acceleration at the end of the oscillation is equals to A equals to W square what? A. W squared A. That is what? Acceleration at the what? End of the oscillation. That is at the extreme positions. Are you getting it? Yes. And so A equal to W squared A. What is your W? W is equal to 2 pi F all squared times your what? A. And amplitude is given. Then now all we need to do is to make sure that this 2 cm is in SI unit, that is meter. And to convert it to SI unit, you divide by 100. So we will say that this is 2 times 2 pi times 20, that is the frequency, all squared times amplitude 2 cm to meter all over what? 100. Yes, amplitude must be in meter. So we'll be having 2 shift pi times 20 squared times 0.02. That will be giving us 315.83. 315.83. 315.83 meter per second squared. Yes, remember this is 2 pi f, that is your angular velocity. And when you say 2 times pi, 2 times pi times frequency is 20, then you square it, then times, you make sure that what? This is a meter. Why? Because this hertz is in SI unit, that is per second. So times 0.02, which is 2 over 100. You will be having a 315 meter per second square. Then the next is the velocities at the corresponding instance. So the velocities at the corresponding instance mean the velocities at what? Fixed position. Velocities at fixed position, or at the end of the what? Next question is the velocities at the corresponding instance means get the way we get this one at the middle and at the what? Extreme. At extreme points. They want us to get velocity at middle, velocity at middle, and also velocity at the extreme, velocity at the extreme. So what happened here now? Velocity at the middle. At the middle, the velocity is always what? Maximum, and that is WA, is always maximum. And what is your W? Is 2 pi times frequency, 2 pi F times your amplitude. And what will it be? 2 pi times 20 times 0.02. That will give you the velocity. Yes, remember amplitude must be in meter, that is the SI unit. 2 shift pi times what? 20. We get our W times 0.02. That will be giving you 2.5 meters, equal to 2.5 meter per second. That velocity at the middle. Then velocity at the extreme. At the extreme, the velocities are going to be equals to 0 because it's minimum at the extreme. Yes, we said at the extreme x is equals to a, and so you'll be getting velocity at the extreme to be equals to 0, but velocity at the middle is 2.5 meter per second, so this is meter per second. Okay, we'll go to question number 2. To solve question number 2, the displacement y as a function of time of a particle executing simple is given by this, all times in SI units. Calculate the angular frequency. When you hear angular frequency, it means W. That is 2 pi f. That is what we mean by angular frequency. The period, the amplitude, and the what? Frequency. Are you getting it? So what do we do in this regard? First and foremost, remember that y is equal to what? A sine bracket theta plus or minus what? Phi. It's plus when it is at positive x-axis. It's minus when it is at negative x-axis. Now, because we are dealing with plus here, I will clean this minus and say I'm dealing with. Therefore, y is equal to a sine bracket. Since theta is equal to 2 pi ft, then phi is equal to 2 pi x all over lambda. I will now come and tell them that I need to compare this equation with this equation we have. So comparing the equation, we have y equals to 4 sine bracket 0.2t plus 0.3. That means that from here, comparing a for amplitude is equal to 4 meter. That is the SI unit. Then sine bracket 2 pi ft 2 pi ft is equal to 0.2t. This will cancel this. So what is your 2 pi f? Remember I said 2 pi f is what we call angular frequency. Therefore, 2 pi f, which is equal to W, is equal to 0.2 rad per second. That is your angular frequency. Are you getting it? And so, what about period? To get your period, you need to get your frequency before you get your period. So, let me get my frequency. Frequency will now be equals to what? 0.2 all over what? All over 2 pi. 0.2 all over 2 pi. I get my frequency. 0.2 divided by 2 pi. That one will be giving you 0.03 hertz. Then to get your period is equals to what? 1 over frequency equals to 1 over 0.03. And that will be giving us 1 divided by 0.03 to be 33.3 seconds. And so that is how to solve question number 2. Now to solve question number 3. A 2 kg block vibrates in simple harmonic motion with amplitude 25 cm and period 3 seconds. Find its maximum speed, its maximum acceleration, its maximum kinetic energy, its maximum potential energy, and its total energy. In this case, They did not ask you at the middle or at the center or the one of at extreme position. Just get their maximum. And so to get it, first and foremost, the mass given to me is equal to 2 kg. Then what else did they give me? The amplitude is equal to 25 cm, equal to 0.25 meter. Then period t is equal to 3 seconds. So for me to get my maximum speed, I will tell them that maximum speed is equal to what? WA. Remember, they did not specify where is it located, but you should know that maximum speed is located at the what? At the center. Maximum speed is located at the center of that our what? Diagram. The one of at the center, like this diagram, at the center. This is where the maximum speed is located. Speed at these extreme points are equal to 0, 0. So speed here is 0. Yeah, but at the center on is maximum. Are you getting the gist? And so what we do here is that we now say what is value of our W? W is equal to 2 pi f, or because period is given, we say W is 2 pi over t times A. What is our 2 pi? All over what? 3 times my A is 0.25. Then you press it to your calculator. 2 shift pi times 0.25 divided by 3. We have it to be equals to 0.524 meter per second. 0.524 meter per second. Okay, what about maximum acceleration? Maximum acceleration, where do we have maximum acceleration? Maximum acceleration is located at their extreme points. And so maximum A is equal to W squared what? A. Are you getting it? W squared A. That means this 2 pi over 3, we will square it, times the A is 0.25. Then we get our maximum acceleration. Yes. So we now say bracket 2 shift pi divided by what? 3. Square, right? Yes. Times 0.25. We'll be having 1.097 equals to 1.097 what? Meter per second squared. Yes. W squared A. That's where we have maximum acceleration. Maximum kinetic energy. Kinetic energy maximum is equal to half m W squared A squared. Half m W squared A squared. So how do we do that? 1/2 times, did they give us mass? Yes. 2 times, did they give us W? Yes. 2 pi over 3 squared times, they give us A? Yes. 0.25 squared. So we use our calculator. Times 2 times 2 shift pi divided by 3 squared times 0.25 squared, and that will be giving us 0.274 watt joules. Now, for our maximum potential energy, note that maximum kinetic energy is equal to maximum potential energy and is equal to total what? Energy. So this one will be sweeter. Equals to 0.274 watt joules. Maximum kinetic energy is equal to maximum potential energy is equal to total energy equals to 0.274 joules. So if you find this video helpful, please don't forget to follow us, click subscribe, share to your friends, comment. See you next class.